Now, let's go back and try and finish this. ये obviously बहुत ही आसान है. This is from page 12. You have your moles and percentage questions where you have empirical formulas के questions uh, or yield के questions. So we're going to do a few questions. For example, this one over here on your screen. ठीक है, I'm going to take out the calculator as well. Now this question, it's all about per- anything that's involving percentage. वो कह रहा है कि garden fertilizer is said to have a phosphorus content of 30%, P2O5 soluble in water. And you're being asked, okay, what's the percentage of by mass of phosphorus in the fertilizer? So how would you do this question? So we're going to try and solve this question. Okay, there's a fertilizer with 30% P2O5 soluble in water, and you're being asked to find the percentage of phosphorus in the fertilizer. So पहले तो I'm going to pick up क्योंकि there's no mass given, सिर्फ percentage given है. So the first thing I'll do is कि I'll assume the mass. ठीक है, assume कर लो mass 100 grams of fertilizer का. तो it's a 100 gram fertilizer. ठीक है, that's तो उसके अंदर P2O5 कितना है? The amount of P2O5 would be 30 grams. अगर 30%, so that means this fertilizer has 30 grams P2O5. The thing that you have to figure out is okay, you found 100 gram fertilizer with this 30 grams P2O5. So in this P2O5, how much phosphorus there is? How would you figure that out? So you can calculate the percentage. And how can you do that? How do you calculate how much phosphorus there is? So एक molecule में there are two phosphorus atoms. So that's 31 into 2 divided by the total. Phosphorus 31 होता है. Divided by the total mass. So P2O5 is 2 phosphoruses and 5 oxygen. So that's 31 into 2 plus that's 16 into 5. ये ये आपके पास fractional percentage आ गई and you multiply that by 30. When you do this, let me take out my calculator as well. So now when you do this calculation on the calculator, it's going to be 31. So it's basically 62 and it's being divided by what? 62 plus 16 into 5 is 80. तो आपके पास परसेंटेज आ रही है 0.43 और 43% into 30 grams कर लो. So I'm going to multiply 0.43 into 30. And I get 12.9. So I'm getting 12.9. Probably 12.9 से ज़्यादा accurate होना चाहिए. 62 ये आप calculator पे करके देख लो. So what I did was the percentage I assumed it was a 100 gram fertilizer. So उसके अंदर अगर 30% P2O5 है, so I assumed it's going to be 30 grams of P2O5 because 30% of that would be P2O5. फिर P2O5 के अंदर I figured out how much phosphorus would there be. तो मैंने उसको percentage से multiply कर लिया. Phosphorus की, how would you calculate the percentage of phosphorus? The amount of phosphorus in one molecule divided by the total. और उसको into 30 grams कर लिया. तो I figured out इस 30 grams में ना there's 12.9 grams और अगर मैं approximate करूँ तो it's basically 13 grams. I'm going to look for the closest answer. So at the end of the day, your 100 gram fertilizer has approximately 13 grams of phosphorus. So the correct answer is going to be A. कि percentage wise कितना phosphorus हो गया? कि out of 100 you have 13 grams of phosphorus. Is this answer clear to everyone? Yes or no? अच्छा, so फिर ठीक है. Uh, Similarly, you have questions about yield. As a similarly, you have questions about yield. Empirical formula. I'm not going to. इस क्वेश्चन के ना एक दो एग्जांपल्स कर लेते हैं इसके पास. You're given कि there's 62% yield of product is achieved. So there's what is yield? So we're going to quickly write what the formula of yield is. Yield is 1 second. अच्छा तो यहाँ पे yield का formula हम ऐड कर लेते हैं. The formula for yield is ठीक है, which you should already be knowing. A percentage yield is the actual or the experimental over the theoretical or calculated into 100. Theoretical is the one that you the percentage yield is actual is the one that you in reality get. Theoretical is the one that you're getting on your calculator when you're working things out on paper. तो अगर आप assume करते हो कि let's say some substance उसकी output जो है वो theoretically on paper should come out to be 100 grams. Like in reality, when you do an experiment, it comes out to be 70 grams. So your yield would be 70%, 70 over 100. But you expected 100, but in reality you got 70. Actual जो है वो usually it's always lesser. It could be more, but it's usually lesser because you're not using pure reactants in reality. And the other thing is that a lot of times the reactions don't go to completions. Most reactions don't complete. So which is why a lot of the reactants they remain unused. As anyways, ये yield है. We can try and do a few questions about this. ये कर लेते हैं. Um, His question के अंदर he's saying that there's 74 grams of butanol and it's producing 44.64 grams of butanol. Now butanol you can simply Google it for now. It's C4H9OH. अच्छा तो and butanone would be C4H8O. Now again you don't have an equation and I told you कि a lot of times you just need to figure out the ratio. तो एक molecule से एक molecule ही बनेगा. If it's C4H9 and OH, then you're going to get C4H8 and O. So it's going to be 1:1. So the first thing you're going to do is you're going to try and figure out कि 74 grams में कितने moles हैं. पहले तो theoretical calculate करो. तो moles is mass divided by mR, so it's going to be 74. और इसकी अगर mR calculate करो ना, it's 12 times 4, that's 36. Plus 16, that's this is 36. Plus 16 plus 10. Is this correct? C4H9 and OH. Nee, sorry, 12 times 4 is 48. 48 plus 16 is 62 plus 10. 60, that's going to be 64 plus 10, 74 ही बन रहा है. So this comes out to be 1 mole. So theoretically, on paper, इसके moles कितने होने चाहिए? It should be exactly the same, 1 mole. Like he's saying that the yield is 62%. So you're not going to get 1 mole. You're going to get 62% of that. So 1 mole का 62% क्या होगा? It's going to be 0.62 moles. So in reality, the actual number of moles that you're going to get based on this yield is going to be 0.62 moles. और फिर आप इसकी MR से multiply कर सकते हो to find the mass. The MR of this substance is going to be 48 plus 16, that's 64 plus 8 is going to be 72. So the MR comes out to be 72 and it's going to be 0.62 multiplied by 72. And if we do that, star 72, we get 48 point. We get 48. नहीं इसकी MR दोबारा check कर लो. 48 plus 16 is 64. 48 plus 16 is 64 plus 8, 72. 72 into 0.62. हाँ जी 0.68 मैंने गलत लिखा हुआ है. So 0.62 star 72. That gives me 44.64 grams, and that is exactly, so this first statement is true. ठीक है, और बाकियों का भी आप इसी तरह चेक कर लो. Butane 1 all होगा. Make sure that if the yield is 62%, so whatever the theoretical value is, you're going to get 62% of that. Is this question clear to everyone? Yes or no? अच्छा, so moving on, most yield के questions, I'll just send you a playlist on this. Shouldn't be an issue. कोई देख लेता हूँ कि कोई अगर मुश्किल question हो. Uh, but most of them would be very simple. अच्छा, now ये percentage वाला तो आसान है. I said now one thing that I wanted to do was ये questions be usually easier. There's one thing that needs to be done, and that is more than redox that we need to do. So we can start by first discussing redox reactions. उसका थोड़ा सा ना हम quickly ना फिर हम moles पे आएंगे. So we're going to briefly and quickly cover redox reactions, and then we're going to continue with moles. So हमारा redox reactions is nothing new in redox reaction except for the fact that uh, oxidation and reduction की हमने revision करनी है, what we studied in O levels. The moles and redox. So the first thing is a quick recap of redox reactions. Redox is reduction and oxidation. Reduction is a gain of electrons. Vice versa, you have oxidation, which is a loss of electrons. Now, there are other words to describe this as well. This is the correct definition. When you are asked what is redox, this is exactly what you're going to write. Now, बाकी क्या चीजें थी कि when something gains electrons, the oxidation state decreases. Then there's another way of figuring out a reduction, and that is a gain of hydrogen, or you can say loss of oxygen. But a lot of reactions don't have hydrogen and oxygen in them, so ये वाली जो last two definitions, they don't usually apply to many reactions. So oxidation state वाली ना, that's the most appropriate one to apply. और ये इसका opposite होगा, vice versa. ठीक है, it's going to be oxidation state increases and there's going to be a gain of oxygen and a loss of hydrogen. I said now the thing with reduction and oxidation is okay, you need to figure out oxidation state. What is oxidation state? Now I'll just first briefly introduce what is oxidation state. क्योंकि हमने पूरे reaction के अंदर figure out करना है who's gaining electrons, who's losing electrons. There's a difference between charge and oxidation state. Uh, a charge is when an atom can get uh, two, three types of charges. For example, H could be completely plus one. Now, plus one means that it has lost an electron completely. Okay? It has lost exactly one electron. H could be in a molecule, it could be partial positive. Partial positive indicates that it's slightly losing electrons. Or in H could be completely neutral, or it could be partial negative. So it could be partial negative, or it could have a charge of -1, which means it has gained 1 electron, right? So, so these are different states that an H can exist in. Now, these are charges. When you describe charges, charges जो होते हैं, they, if it's, you have to describe whether it's a slight charge or whether it's a full charge or uh, partial positive या partial ये completely +1 है. Now, when it comes to oxidation state, you're not interested in whether it's losing electrons partially or whether it's gaining electrons partially. What you're interested in is whether it's losing electrons or not. So when it comes to oxidation state, H+1 or H partial positive का दोनों का मतलब एक ही है. You're going to treat them as if it's ionic. You're going to treat कि जी H+1 है तो it lost an electron. Even if it's a, if even if H is partial positive, तब भी आप कहोगे कि हाँ नहीं, it has lost an electron. Although it is partially losing an electron, but you're going to treat it as if it's ionic. इधर H के ऊपर कोई चार्ज नहीं है तो इसका मतलब it didn't lose or gain electrons. H अगर partial negative होगा ना, slightly negative, you're going to treat it as if it has gained an electron. ठीक है, we're not interested कि उसने partially gain किया या fully gain किया. So when it comes to oxidation state, these two things, slight positive or fully positive ion, they mean the same thing. ठीक है, for example, if you have a molecule of HCl, so HCl is a covalent molecule. ठीक है, which basically means there is no +1, there is no -1. I mean, it's a polar molecule. H is partial negative, Cl is partial. Sorry, उल्टा कर दिया. Cl ज़्यादा electronegative होता है. अच्छा, reality ये है कि the charges on H and Cl, it's a covalent molecule, but they are only very slight charges क्योंकि these electrons are lying closer to, are slightly lying closer to Cl. But when it comes to oxidation state, आप इसको +1 कहोगे, इसको -1 कहोगे, ठीक है? So that's the only difference between what an oxidation state is and what an actual charge is. Actual charge में आप ख्याल रखते हो कि स्लाइट है या फुल पॉजिटिव है. ऑक्सीडेशन स्टेट में आप इसका ख्याल नहीं रखते, आप बस उसको कहते हो कि अगर स्लाइटली भी इलेक्ट्रॉन लूज किया ना, यू गोइंग टू ट्रीट इट एज इफ इट्स लॉस्ट एन इलेक्ट्रॉन. Is this idea clear to everyone? The difference between oxidation state and charge. I said, Naila, I'm going to repeat a few. I'm going to do another example. ठीक है? NaCl है. ठीक है? Let's pick a dot and cross diagram. You have NaCl. Now, in an NaCl molecule, Na had 1 electron in its outer shell. I'm just drawing the outer shell. Cl had 7 electrons in its outer shell. I said it was a metal and a non-metal reaction. If you know this thing, ये मैं थोड़ा सा background भी दे दूं. There's a thing called electronegativity. Now, electronegativity is the tendency for an atom to attract electrons or pull electrons, bonded pairs of electrons towards itself. So, electronegativity जो होती है, that increases to the right of the periodic table. The elements to the right are always more electronegative, and the elements on the top as well are also more electronegative. ठीक है, this corner is one of the most electronegative parts of the periodic table. So why is that? The reason these elements are electronegative is okay, when you move to the right of the periodic table, you have more protons. So the attraction for electrons keeps on increasing. And elements that are higher up in the periodic table are more electronegative because they're smaller. So उनका जो nucleus होता है ना, that's more exposed. I mean, if it's a smaller atom, the nucleus is very exposed, so it would have a stronger tendency to attract electrons. Bottom वाले जो होंगे ना, that they would have, the nucleus would be covered by lots and lots of shells. तो बाहर का electron जो है ना, वो that would not be able to, it's not going to be strongly attracted to the atom. The simple rule ये है कि जो छोटा atom होता है ना, that attracts electrons very strongly. The bigger atom doesn't really attract electrons that strongly. तो ये तो electronegativity का idea. So what happens is कि Na is over here and Cl is on the extreme right. Cl has 17 protons, which means that it has a very strong attraction for electrons. अब NaCl के case में you already know what's going to happen. Okay, this electron over here is going to jump and it's going to get attracted to Cl. And the Cl over here would get a -1 charge and Na over here would get a +1 charge. Okay. So right now it's you're getting a +1 charge and you're getting a -1 charge. That is oxidation state. Okay, Na has an oxidation state of +1, Cl has an oxidation state of -1. इस केस में चार्ज और oxidation state में there is no difference. But when it comes to an HCl molecule, ठीक है, if I draw the dot and cross diagram for an HCl molecule, ठीक है, एक दो examples करते हैं. So now if I draw a dot and cross diagram for an HCl molecule, now in an HCl molecule what happens is okay, there are two non-metals. Now the problem with non-metal is they're never going to lose electrons. तो Cl को एक electron चाहिए, it's going to try and pull that electron. लेकिन H is not going to lose its electron. वो पूरा H ही उठ के ना उसके पास आ जाएगा, bringing its electron with it. So that's how a covalent bond is formed, because no one ended up losing electrons. No one was trying to lose electrons. They were all trying to gain electrons. So the electrons are stuck over here in the middle. ठीक है, so the electrons are stuck in the middle. कोई भी atom उनको gain नहीं कर सका. अच्छा, but in this case, what happens is that these electrons over here, they're not evenly distributed. They're not right. They're not exactly in the middle. Cl has a stronger pull towards. Cl has 17 protons. Okay, Cl is right here in the corner. It's very electronegative. Cl has a very strong tendency to attract electrons. So Cl इन electrons को ना अपनी तरफ खींचेगा. And this molecule over here uh, would not be a perfectly covalent molecule, because these electrons would be lying closer to Cl. If they're lying closer to Cl, the electrons थोड़े से यहाँ पे ज़्यादा हो गए हैं, तो this side would have a very slight negative charge, this side would have a very slight positive charge. यहाँ तक idea clear है कि this is known as a polar molecule, which we will study in detail. It's a polar covalent molecule where the electrons are not evenly distributed. अच्छा, is this clear? ठीक है. अच्छा, now what I'm just saying is कि this is the charge on the molecule, partial negative, partial positive. लेकिन जब हम ऑक्सीडेशन स्टेट की बात कर रहे होते हैं ना, तो हम बेसिकली डिस्कस ये कर रहे हैं कि किसने इलेक्ट्रॉन गेन किया, किसने इलेक्ट्रॉन लूज किया. आई एम नॉट रियली इंटरेस्टेड कि उसने पार्शली गेन किया या पार्शली लूज किया. यू हैव दीज इलेक्ट्रॉन्स ओवर हियर. हु गेन दीज इलेक्ट्रॉन्स? लाइक दे क्लोजर टू Cl, right? So Cl is the one that's basically gaining electrons, and it exactly gained one electron. मतलब एक तो उसका अपना ही था, एक उसने हाइड्रोजन से गेन किया. Although it's only partially attracting it, but I'm not really concerned with that. Redox के अंदर ना, you're not interested. आप बस ये देखना चाह रहे हो कि who's gaining and who's losing. So Cl is the one that's gaining. So Cl के ऊपर क्या charge होगा if it gains one electron? It would be -1. That would be the oxidation state of Cl. And H is the one that has lost one electron. मतलब एक तो Cl का था, अपना उसने एक ही lose किया, ठीक है? So it lost one electron, hence it will have a charge of +1. So what happens in oxidation state is simply that it's the charge on the element if your normal covalent molecules behaved ionically. ठीक है, so if HCl were to be treated as an ionic compound, कि दो इलेक्ट्रॉन किसके पास गए हैं, is it Cl के पास या H के पास? तो although वो slightly Cl के पास गए हैं, लेकिन आप कहोगे ठीक है Cl ने इलेक्ट्रॉन गेन कर लिए, ठीक है, because you're only interested in redox. रिडक्शन किसकी हुई है, ऑक्सीडेशन किसकी हुई है. Cl ने gain किया इसलिए oxidation state is -1. H has lost, so its oxidation state is +1. So it's, although reality में जो charge है ना, that's partial positive. You're going to give it +1. नहीं, exactly, Mikhail. That's what I'm trying to state here is कि क्योंकि हम redox की जब बात कर रहे हैं ना और oxidation state की बात कर रहे हैं, we're only interested in is who's gaining electrons and who's losing electrons, absolute terms में. तो who's +1, who's -1, that's it. Uh, तो इसलिए ना oxidation state is slightly different from charges. Charges can be partial positive and they can be partial negative. ठीक है, तो oxidation state जो है ना charges ही होते हैं लेकिन बस वो absolute terms में होते हैं. Mikhail, you get my point? Is this point clear to everyone? ठीक है, so there's, चल ठीक है, तो that there's a, तो इसलिए ना never ये you're going to lose marks for this कि अगर आपने, if they are asking for the charge और आपने partial positive if they're asking for the charge और आप +1 लिख आते हो, I mean that's obviously wrong. So make sure you know the difference between when they're asking for the charge and when they're asking for the oxidation state. एक और molecule कर लेते हैं कि I have a molecule of oxygen. ठीक है, one more example. I have a molecule of oxygen and this oxygen atom has 6 electrons and it's bonded to fluorine. So now fluorine is one of the most electronegative elements out there. It has 7 electrons. तो oxygen को उसका electron चाहिए. It's a non-metal. It's not going to lose electrons. तो वो पूरा साथ ही आ जाएगा. So the entire atom is going to come along. हाँ, मतलब oxidation state is also known as the valency. Although valency, remember valency जो है ना, ये जो term है ना, that's a very ill-defined term. So my advice would be not to use valency anywhere. ठीक है, valency has, in different contexts, it has many different meanings and it can get very confusing. क्या valency किसे कह रहे हो? ठीक है, मतलब valency का ये भी मतलब है कि it's the number of electrons in the outer shell. Oxidation state को भी valency कहते हैं. So valency is kind of ill defined. So try not to use the term valency. अच्छा, ये एक और molecule कर रहा हूँ कि I have another fluorine atom and that fluorine is also, it has 7 electrons. अच्छा, anyways, you have this molecule. Now try and guess uh, who's more electronegative. Fluorine is right in the corner. There's nothing more electronegative than fluorine. So now I'm interested in the oxidation state. Where would these two electrons, which side would they drift towards? Which side would they be closer to? Fluorine or oxygen? Because fluorine is more electronegative. So these electrons would be closer to fluorine, slightly closer to fluorine. Although electronegativity is इतना फर्क नहीं, oxygen and fluorine are right next to each other. So that means they almost have the same electronegativity. Oxygen has 8 protons. Fluorine, on the other hand, has 9 protons. So there's not much of a difference. I said these electrons over here, they're also closer to fluorine. So this fluorine will have a charge of -1. This fluorine would also have a charge of -1. Oxygen, on the other hand, would have an oxidation state of +2. Okay, it lost one electron to that fluorine, lost another electron to that fluorine. So the oxidation state is +2. The reality में these are not the charges on these atoms. ठीक है, मतलब partial positive होगा, partial negative होगा. But this is the oxidation state. अच्छा, is this clear? ये वाला example, is this clear? अच्छा, now the next thing we're going to try and do is, okay, we can't obviously use electronegativity every time we want to figure out oxidation states. Not every time. Although when you get stuck with some molecule, you can use oxidation states. But you can't use oxidation states. There's a simple method that you did in O levels, and that is you can come up with a table, and that can pretty much guide you about the oxidation states of different elements. For example, you have Any free उस table के अंदर ना any free element, neutral element, the charge is going to be zero. The oxidation state is going to be zero. Then for compounds, the rule is group one is always plus one in a compound. Group two is always plus two, and group three is always plus three, and so on. Transition metals, they have variable oxidation state, so unless it's not mentioned, you have to calculate them. Then you must know that oxygen has an oxidation state of -2, usually, with plenty of exceptions. I mean, we just saw an exception. ठीक है नहीं Mikhail, send me those questions. I mean, if you're done till page 11, so we can have a class on that separately, and we can solve those questions. ठीक है वो questions attempt करने हैं. That's very important. ठीक है ये याद रखो, ये सारों को मैं बता रहा हूँ कि a lot of questions that you attempt, you're not able to solve them. ठीक है वो उसके लिए फिर हम separate, we can have a separate class on that. Make sure you unko compile kar lo, and we can go through them quickly in some other class. ठीक है ये लाजमी करना है. This is very important क्योंकि you won't be able to do all the questions that you attempt, और खासतौर पे एएस के अंदर a lot of questions. तो ये हैबिट बनाओ. ठीक है और थोड़ा ऑर्गेनाइज तरीके से कि मेक श्योर कंपाइल द क्वेश्चंस एंड वी कैन देन डिस्कस देम. या ग्रुप के ऊपर पोस्ट कर दो, हम फिर वन बाय वन ना उधर ही आई कैन शेयर द स्क्रीन एंड आई कैन we can discuss each one of the questions. So oxygen -2, but plenty of exceptions. One exception is the one that was with fluorine, except with fluorine. Or there's another one which is H2O2. I say H2O2 के अंदर this is -1 actually, and I can do the H2O2 dot and cross diagram as well क्योंकि uh, sometimes they've asked for the H2O2 dot and cross diagrams in some of the questions. So we can sort of H2O2 पढ़ते हुए ना we can sort of go over this as well. H2O2 का जो molecule होता है ना, that is something like this. You have two oxygen molecules, and oxygen likes to share two electrons, so this oxygen goes and shares one electron. But now this oxygen still needs one electron over here. So you're going to bring in an H atom. The H atom would provide the second electron. Okay, and similarly over here as well. Another H atom is going to provide this oxygen with its second electron. So anyways, this is it. This is an H2O2 molecule. So why is it -1? -1 is like if you look at the electrons, these two electrons over here, they are going to be closer to oxygen. So oxygen ने कितने electron gain किए? एक किए, -1. These two electrons would be closer to this oxygen. Oxygen is more electronegative. So oxygen ने कितने electron gain किए? एक किए, -1 हो गया. H lost one electron, so it became +1. This H also became +1. What about these middle electrons? Now these middle electrons, both sides are oxygen, so they are equally being pulled by both oxygens. I mean, there's an equal pull. So these electrons, which are right in the middle, they are neither gained by this oxygen or they gained by this oxygen. So this is perfect covalent sharing क्योंकि दोनों sides पे oxygens है. So these electrons are neither gained nor lost. तो ये बिल्कुल बीच में पड़े हुए हैं. So in reality, oxygen only gained an electron from H from one side. इनको ना वो gain कर सके ना lose कर सके. So the net result is that it only gained one electron, -1, and that coming from H. Okay, so this is the reason why oxygen is -1 in an H2O2 molecule. Anyways, most of the time it's going to be -2. Oxygen would be -2. और इसी तरह H के कि when it comes to oxidation state, most of the time it's going to be +1. ठीक है, except in metal hydrides. Now, when it comes to metal hydrides, what happens is the metal actually ends up losing electrons. वो +1 हो जाता है, H -1 हो जाता है. So, except metal hydrides, H is always +1. तो मैं फिर से repeat कर रहा हूँ. This is the table of oxidation states that you're going to use to figure out the oxidation states of all the other elements. Group 1 +1, group 2 +2, group 3 +3. Oxygen is always -2, apart from a few exceptions, and H is always +1, again apart from a few exceptions. Yeah, the clear है? Yes or no? Is this clear to everyone? I said now the next part is how do you figure out the oxidation states of elements whose oxidation state you're not sure of? Again, this has already been done in O levels, so you're not sure of. Example is an SO4 2 minus ion. So जो ऊपर table given है ना, it only has oxidation states of a few elements. So how do you figure out the oxidation state of sulfur over here, for example? So the rule is individual oxidation states must add up to the total charge or the overall charge. They add up to the overall. So you have sulfur, which is unknown. So I'm going to take it as X. You have oxygen, and oxygen I know it's -2, and there are 4 oxygen, so that's -2 times 4. And the individual charges must add up to the total charge, which in this case is -2. And X, if you solve for X, comes out to be +6. इसका मतलब है कि the sulfur over here was +6, and the oxygen over here was -2. And remember, when you talk about oxidation states, you're talking about a single atom of the element. मतलब आप ऑक्सीजन की ऑक्सीडेशन स्टेट जो है ना वो चारों ऑक्सीजन मिला के नहीं बात करोगे. You'll only talk about the oxidation state of a single oxygen atom. So that's how you're going to try and find the oxidation states of different elements. Let's do another example. You have, for example, you have K2Cr2O7. So I need to find the oxidation state of K2Cr2O7. K is in group 1, so that's +1. Again, there are 2 Ks, so that's +1 times 2. Cr over here is unknown, so that's X and into 2. And there's 7 oxygen, so that's -2 times 7. They should all add up to be equal to 0 because the overall compound has no charge. And then you start solving for X. If you solve for X, it's going to come out to be 2X is equal to -14. Udhar get 14, so it's going to come out to be 12. And X then comes out to be 6. So based on our calculation, this is +1, this is +6, and this is -2. ठीक है? Is this clear to everyone? याद है सारों को? ठीक है? तो ये O levels में किया हुआ है. So it's and you must know how to figure out the oxidation state. I'll just give you some idea about. Be careful about a few things. Specifically, um, when you're trying to find oxidation states this way, make sure treat polyatomic ions separately. I mean, I'll give you an example. You have to be very careful doing this. For example, you're given a molecule of ammonium nitrate. ठीक है, it's NH4+1 NO3-1. मतलब एक्चुअल में तो मॉलिक्यूल जो होगा वो तो कंबाइंड लिखा होगा. Now, a lot of people make this wrong assumption. They think that both nitrogens over here they have the same oxidation state. ठीक है, which is not true. ठीक है, it's not the same oxidation state. You have to treat them as separate entities. This is NH4+1 and this over here is NO3-1. ठीक है, treat them as separate. और जब separately treat करोगे n का नहीं पता तो that's x, hydrogen is +1 so that's into 4 and you add up all of them to be equal to +1. तो x comes out to be -3. तो इसका मतलब है कि nitrogen over here had an oxidation state of -3. लेकिन over here if you do the same working on the other side, n is unknown so that's x, 3 oxygen so that's -2 into 3 and the total charge must add up to be equal to -1. So x comes out to be +5. So nitrogen over here is +5. ठीक है, so make sure you're able to or capable to identify polyatomic ions. ठीक है, if a compound is given, make sure कि उसको ना you split it into the individual ions that it's made up of. Otherwise, you're going to get a wrong oxidation state. ठीक है, ज़्यादातर का यही करना. Specifically when the same thing appears in both sides. इस चीज़ का बस ख्याल रखना. ठीक है, is this clear? अच्छा, now the more important and slightly more difficult thing. Now the important thing is, because we have to relate to moles, the important thing is that when you're trying to balance a redox equation, one you have to be very careful about one thing. Okay? When you're trying to balance redox equations, we're going to learn how to balance redox equations. Now there's one issue, and that issue is that a redox equation, not only do the atoms of elements need to be balanced, like a normal conventional equation, the number of electrons that are being gained and the number of electrons that are being lost, they must also be equal. Okay, so I'll give you a very small example. I have this reaction in which Na and Al3 plus are reacting. Okay, now this is a very simple reaction and it's producing Na plus 1 and Al atom. So a simple reaction. Now atom wise, this equation looks perfectly balanced. I mean, there's one sodium on both sides, there's one Al on both sides. ठीक है, नहीं ठीक है, मिकाइल will do this. इसके हम काफी questions अभी करेंगे, ठीक है. अच्छा, so atoms are getting balanced. अब ये एक चीज का ख्याल रखो कि when you're trying to balance a redox equation, the number of electrons, not only do the atoms have to be balanced, the number of electrons gained and the number of electrons lost, they must also be equal. तो अगर हम इस equation को, simple equation को, if we look at it very carefully, how many electrons are lost? Just one electron, right? Sodium went from sodium neutral atom to sodium plus 1. And how many electrons are being gained by aluminium? Al went from 3 plus to 0, so that means it gained a total of 3 electrons. So the issue is that this equation is not balanced. Why? Because the amount of electrons that are being lost and the amount of electrons that are being gained by aluminium, they're not coming out to be equal. So atom-wise, the equation balanced, but it's not balanced according to the number of electrons that are being lost by sodium and the number of electrons that are being gained by aluminium. They must always be equal. और इस केस में आसान काम ये है कि आप सोडियम को ना 3 से मल्टीप्लाई कर दो. If you have 3 sodiums, the number of electrons lost would be 3 as well. So now the number of electrons lost and the number of electrons gained have now become equal. तो मैंने बस सिंपल सा एग्जांपल किया, अभी हम इसको बहुत डिटेल में नेक्स्ट क्लास में करेंगे, बट इज दिस इक्वेशन क्लियर? कि you have to be careful about a few things when you're trying to balance redox equations. ठीक है, ये simple equation है. ठीक है, is this clear everyone? Yes or no? तो ठीक है, just make sure, क्योंकि moles के अंदर ना this is going to be very important, कि a lot of people would think that an equation is balanced when in fact it's not balanced. ठीक है, क्योंकि कहीं किसी भी इक्वेशन में ना लिखा नहीं होगा कि ये जो इलेक्ट्रॉन्स है ना, ये तो मैंने खुद लिखे हैं ना, तो किसी भी इक्वेशन में लिखा हुआ नहीं दिया होगा कि द इलेक्ट्रॉन्स आर नॉट बैलेंस्ड. यू कांट इवन सी द इलेक्ट्रॉन्स. मतलब अगर ये मैं हटा दूं जो मैंने वर्किंग की है, यू वोंट इवन बी एबल टू सी द इलेक्ट्रॉन्स. तो वो आपको खुद फिगर आउट करना पड़ता है whether the equation is balanced or not. तो इसके ऊपर ना we're going to study this in detail in the next class, how to balance redox equations. ठीक है. और मिकाइल क्रिएट अ लिस्ट या वो पिक्चर्स जो है ना उसके ऊपर व्हाट्सएप ग्रुप के ऊपर ना क्वेश्चंस के लेके सेंड कर दो. ठीक है, ताकि वहाँ पे कंपाइल हो जाए तो उधर से ही मैं रेफर करके ना वी कैन सॉल्व दोज क्वेश्चंस. बल्कि स्टार्ट में ना हम वही क्वेश्चन सॉल्व कर लेंगे नेक्स्ट क्लास में. अच्छा, मेक श्योर एवरीवन, बाकी सारे भी ना, ये किधर हमारी मोल्स की वर्कशीट, हम यहाँ तक ना जितने भी क्वेश्चंस थे, दिस इज पेज 16. Try and go through most of the questions till page 16 and see if you have problems. You can remember it's all 50% जो है ना, that's about attempting questions. Theory वाला part जो है ना, that's easy. Solving questions is the difficult part. चलिए ठीक है. Okay then, any questions? नहीं, we can continue with this tomorrow then in the next class. ठीक है. So okay, take care. Allah Hafiz.